There is a moment every human being has experienced. You are walking through a crowded city, and for no reason you can name, you cross to the other side of the street. You change your route. You avoid the alley. You put the car keys in your pocket instead of your bag. Nothing visible told you to. No alarm sounded. No warning appeared on a screen. The data that prompted the decision never reached your conscious awareness. You simply knew. Hours later, you discover that something was wrong in exactly the place you avoided. A mugging, an accident, a confrontation. You did not witness any of it, and you cannot explain, even to yourself, why you moved. The closest word for what happened is instinct, or gut feeling, or the phrase that covers everything it cannot explain, a sixth sense. Most people treat this phenomenon as either mystical or coincidental. The mystical interpretation says that human beings have access to information beyond the physical, that consciousness extends beyond the skull, that some force outside of ordinary biology communicates danger, opportunity, and truth to those willing to listen. The coincidental interpretation says that you crossed thousands of streets uneventfully, that the human mind is a pattern-seeking machine, and that you simply remember the one time your arbitrary choice seemed to mean something. Both of these interpretations are wrong. The truth is stranger than mysticism and more impressive than coincidence. Your brain is a machine of staggering computational power that processes vastly more information than conscious awareness ever receives. Every second, your sensory systems deliver an estimated 11 million bits of information to your nervous system. Your conscious mind handles approximately 40 to 50 bits of that. The remaining 10,950,000 bits are processed below the threshold of awareness, sorted, filtered, weighted, compared against decades of stored experience, and acted upon, all without your knowledge, all without your permission, and all with a speed and accuracy that conscious deliberation cannot match. What people call intuition is not a sixth sense. It is the first sense. It is the native operating mode of a brain that evolved long before the prefrontal cortex developed the capacity for language, logic, and deliberate analysis. It is the output of neural systems so fast, so deep, and so sophisticated that consciousness receives only the verdict, the feeling, the certainty, the inexplicable knowing, without ever seeing the evidence that produced it. This is not a metaphor. This is neuroscience. And if you find it remarkable that your own mind is doing things you are completely unaware of, wait until you discover how much of what you call yourself, your decisions, your preferences, your personality, your sense of who you are, originates in processes you will never consciously access. If you enjoy deep dives into the science of the human mind, the real science, not the self-help distortion of it, consider tapping that like and subscribe button. It helps more than you know, and I genuinely appreciate every single one of you. Now get comfortable. We are going somewhere most people never go. Into the part of your brain you cannot see. Chapter 1. The Information Problem. Why your brain cannot tell you everything it knows. Begin with a number that should fundamentally change the way you think about your own mind. Your retinas alone, just the two thin sheets of light-sensitive cells at the back of your eyes, transmit approximately 10 million bits of visual information per second to your brain. Your skin contains roughly 100,000 nerve endings per square centimeter in the most sensitive areas, each capable of signaling touch, pressure, temperature, pain, and vibration independently. Your inner ear monitors not just sound, but the precise three-dimensional orientation and acceleration of your head at every moment. Your olfactory system can distinguish approximately 1 trillion distinct odors, according to research published in the journal Science. Your body has internal sensory systems tracking blood pressure, blood oxygen saturation, blood glucose levels, the state of every major organ, the tension in every muscle, and the chemical composition of every breath you take. All of this information arrives continuously. All of it is processed. None of it, almost none of it, reaches consciousness. The concept of selective attention is well established in psychology. Cognitive scientist George Miller's landmark 1956 paper established that conscious working memory can hold approximately 7 items at once, give or take 2. Later research refined this estimate downward, suggesting that genuine working memory may hold only 3 to 4 distinct chunks of information simultaneously. Daniel Kahneman, the Nobel laureate psychologist, popularized the framework of System 1 and System 2 thinking. System 1 being the fast, automatic, largely unconscious processing mode, and System 2 being the slow, deliberate, effortful, conscious reasoning that humans tend to think of as real thinking. But the bottleneck is even more severe than popular psychology suggests. Information processing researchers have measured the bandwidth of conscious thought by tasks as simple as reading text or performing mental arithmetic. The consistent finding is that deliberate conscious processing, the kind you experience as active thinking, runs at something like 40 to 50 bits per second. Against an incoming stream of 11 million bits per second from the senses alone, this means consciousness is receiving and processing less than 1/10,000th of the available information. The brain does not solve this problem by discarding the other 10 million bits. It solves it by processing them unconsciously. Your nervous system contains approximately 100 billion neurons, each forming on average 7,000 connections with other neurons. The total number of synaptic connections in the human brain is estimated at around 100 trillion. The vast majority of the activity across this network, the firing patterns, the signal transmissions, the chemical releases, the electrical cascades, never generate conscious experience. They run constantly in parallel, processing information at speeds and scales that consciousness cannot approach. The question neuroscience has spent decades trying to answer is not whether unconscious processing exists. That question was settled definitively by the 1980s. The question is what the unconscious brain actually does with all that information, how sophisticated its processing really is, and how it communicates its conclusions to the part of the system that experiences the world consciously. The answer to those questions is what most people, when they encounter it, call intuition. Chapter 2. The body knows first. Somatic markers and the evidence from neurology. In the early 1990s, neurologist Antonio Damasio at the University of Iowa was studying patients with damage to the ventromedial prefrontal cortex, a region of the brain located just behind the forehead that bridges the gap between emotional processing and rational decision-making. His patients were, by conventional cognitive measures, entirely functional. Their intelligence was intact. Their memory worked normally. They could analyze situations, identify options, and articulate reasons. They understood social norms. They could perform logical operations. In nearly every measurable dimension of cognitive ability, they were indistinguishable from healthy subjects. And yet their lives had catastrophically unraveled. They made persistently terrible decisions. Business ventures collapsed, relationships disintegrated. Financial choices that any observer could identify as obviously disastrous were made again and again, despite the patient's apparent ability to recognize the problems after the fact. When asked why they had acted as they did, they could provide reasons that sounded rational. But the reasons bore no relationship to what actually guided their behavior, because what actually guided their behavior, the emotional signals that normally operate below consciousness but shape decision-making profoundly, had been disconnected. Damasio developed a theory he called the somatic marker hypothesis. The word somatic means relating to the body. The hypothesis proposes that the brain attaches emotional and physiological tags to memories and scenarios. When you encounter a situation similar to one you have experienced before, your brain does not simply retrieve the factual memory. It also retrieves the associated somatic state, the bodily feelings that accompanied the original experience. A tightening of the stomach, a subtle shift in heart rate, a warmth in the chest, or a chill across the shoulders. These somatic markers are generated by the body's own systems, coordinated by structures including the amygdala and the ventromedial prefrontal cortex, and they bias decision-making before any conscious deliberation occurs. Damasio and his colleagues demonstrated this with a now famous experiment called the Iowa gambling task. Subjects were asked to draw cards from 4 decks. 2 decks were rigged to produce large rewards but occasional catastrophic losses, an overall losing strategy. 2 decks offered smaller rewards but consistent gains, an overall winning strategy. Healthy subjects typically began switching to the winning decks after roughly 50 draws. By about 80 draws, they could articulate why. They had consciously figured out the pattern. But here is the critical finding. The subject's skin conductance responses, a measure of the body's arousal state controlled by the autonomic nervous system, began showing elevated responses to the losing decks after roughly 10 draws. The body was signaling danger about the losing decks before conscious awareness had detected any pattern at all. The somatic signal preceded the conscious insight by approximately 40 draws and thousands of milliseconds of deliberation. Patients with ventromedial prefrontal cortex damage never developed those somatic responses. They continued drawing from losing decks until the end of the experiment, able to explain the rules of the game but unable to feel their way toward the right answer. The implication is profound. The feeling we experience as a gut instinct, the vague physical unease about a business deal, the inexplicable warmth toward a stranger, the sense that something is off about a situation we cannot immediately articulate, is not noise. It is not irrationality. It is information. It is the brain's emotional memory system communicating a pattern match in the only language available to it, the language of physical sensation. Damasio's patients had lost the ability to receive this signal, and without it, their intelligence, formidable and intact, was not enough to prevent them from destroying their own lives. Qui, the architecture of speed. How the brain makes decisions in milliseconds. When a baseball pitcher throws a fastball traveling at 95 miles per hour, the ball covers the distance from the pitcher's mound to home plate in approximately 400 milliseconds. Of that 400 milliseconds, the first 100 are consumed by the batter's visual system registering the release. The neural signal travels from the retina to the visual cortex in roughly 50 milliseconds. Processing the trajectory, velocity, and spin requires additional time. Transmitting the motor command from the brain to the muscles of the arms and wrists takes approximately 150 milliseconds. The actual swing itself consumes another 150 milliseconds. Add these numbers up and you get 450 milliseconds. The batter has less time available than the mathematics of the response requires, and yet professional batters hit fastballs, not always, but regularly, enough to earn multi-million-dollar salaries doing it. How? The answer reveals something fundamental about how the brain operates. The conscious mind, the system that experiences deliberate thought, that asks, "What should I do?" and formulates answers, is not the system that swings the bat. By the time consciousness could process the incoming data and generate a response, the moment would be gone. The system that swings the bat is older, faster, and operates entirely beneath awareness. It is the system of pattern recognition, predictive modeling, and automatic motor response. It sees the pitcher's shoulder angle, the release point, the spin of the ball in the first 100 milliseconds, and it matches those fragments against a library of thousands of previously witnessed pitches stored in implicit memory. It generates a prediction. It initiates a motor response. And it does all of this before consciousness has finished forming the question. The same architecture governs human social perception. Research by Nalini Ambady and Robert Rosenthal at Harvard University, published in a landmark 1992 paper, demonstrated that subjects who watched 2-second silent video clips of professors teaching could predict end-of-semester student evaluations of those professors with accuracy that correlated at 0.76 with evaluations from students who had spent an entire semester in the same classroom. 2 seconds of silent video. No words, no content, no information about the subject being taught. Just movement, posture, facial expression, gesture, and the brain extracted a signal accurate enough to predict what would take an entire semester of experience to consciously confirm. Ambady and Rosenthal called these thin slices of behavior, and subsequent research showed the phenomenon extended across dozens of domains. Judgments about personality, trustworthiness, competence, and emotional state formed in the first milliseconds of an encounter correlate substantially with judgments formed after hours of interaction. The initial impression is not always correct, but it is not random. It is built from real information, processed by systems so fast that the conclusions arrive before the deliberation begins. This processing speed comes from the architecture of the neural systems involved. The amygdala, the almond-shaped structure deep in the temporal lobe that serves as the brain's primary threat detection system, receives sensory input through 2 pathways described by neuroscientist Joseph Ledoux as the high road and the low road. The high road routes sensory information through the cortex, where it is processed in detail, cross-referenced with memory, and analyzed for meaning. This pathway takes approximately 300 to 500 milliseconds. The low road routes a rough, low-resolution copy of the sensory input directly to the amygdala, bypassing cortical analysis entirely. This pathway takes approximately 12 milliseconds. 12 milliseconds, a fraction of a heartbeat. Before your visual cortex has finished processing the shape of a face, before your prefrontal cortex has begun to analyze it, before your conscious mind has registered that there is anything to analyze, the amygdala has already received a signal. evaluated it against a library of emotional memories, and initiated a physiological response. The heart rate shifts. Cortisol is released. The muscles of the face begin to change. The body is already responding to something the mind has not yet seen. This is the neural substrate of the feeling that something is wrong. It is not mystical. It is 12 milliseconds of threat processing in a structure that has been performing exactly this function for hundreds of millions of years. Fomoriastaus, the Experience Library. How expertise shapes intuition. In 1973, Dutch chess master Adrian de Groot published research demonstrating that chess grandmasters, when shown a chessboard position for 5 seconds and then asked to reconstruct it from memory, could accurately replace approximately 26 pieces. Intermediate players could accurately replace about 8. The difference was not explained by superior memory in general. When the same pieces were arranged randomly rather than in positions from actual games, grandmasters performed no better than intermediates, correctly placing only about 8 pieces. The grandmaster's advantage was not memory, it was pattern recognition. A board position from an actual game is not 26 independent pieces. It is a single recognizable configuration, one unit in a library of patterns the grandmaster has internalized from years of exposure to thousands of games. The grandmaster does not see 26 pieces. They see one pattern with a name, a history, an implication, and a next move. Psychologist Gary Klein spent decades studying expert decision-making in high-stakes environments: military commanders, firefighting commanders, intensive care nurses, neonatal care specialists. His research, compiled in his 1998 book Sources of Power, overturned the assumption that expert decision-making is primarily analytical. What Klein found, consistently across domains, was that genuine experts under time pressure rarely engaged in comparative analysis, weighing options against each other, calculating probabilities, constructing decision trees. Instead, they recognized situations as belonging to a familiar category and generated a single course of action almost immediately. Klein described this as recognition-primed decision-making, or RPD. The expert's experience builds a library of situation-action pairs encoded in memory. When a new situation is encountered, the brain does not analyze it from scratch. It pattern matches it against the library. If a match is found, the associated action is generated. The expert experiences this as knowing immediately what to do. From the outside, it looks like intuition. From the inside, it feels like clarity. A firefighting commander described to Klein the moment he ordered his crew out of a burning house seconds before the floor collapsed. When asked how he knew the floor was about to fail, he said he simply felt that something was wrong. Subsequent analysis identified a constellation of subtle signals. The fire was quieter than expected. The heat was higher than the visual evidence of smoke suggested. The fire behaved oddly when water was applied. That collectively corresponded to a configuration the commander's experience had associated with structural danger. He had not consciously analyzed these signals. He had not run through a checklist. He felt it. The feeling was the output of a pattern recognition process so thoroughly internalized that it operated without conscious direction. But Klein's research also identified something that popular accounts of intuition consistently ignore: the domain specificity of expert intuition and its failure conditions. A firefighting commander's intuition about fire is extraordinarily reliable within the domain of building fires in the context of the particular city and construction methods the commander has experienced. Move that same commander to a novel fire type, a wildfire, an industrial chemical fire, a structure built with unfamiliar materials, and the pattern library fails. The situation does not match anything stored. The intuitive confidence remains, but the pattern match is broken, and the action generated may be wrong. This is not a flaw in the system. It is a feature with a danger. The feeling of intuitive certainty is generated by the match between incoming information and the stored pattern library. It does not independently verify that the stored pattern is correct or that the match is accurate. An expert who has developed their pattern library in a biased environment, one where feedback was distorted, where errors were not observed, where certain signals were systematically miscorrelated with outcomes, will generate intuitive certainty that is systematically wrong. And they will feel equally certain whether they are right or wrong. This is the dark side of expertise intuition. We will return to it. Shansidikagi, the predictive brain. Perception is not what you think it is. The traditional model of perception, the one most people implicitly hold, goes like this. The world contains information. Sensory organs detect that information. The brain receives the sensory data and constructs a representation of reality from it. Consciousness experiences that representation. This model is wrong. The actual neuroscience of perception has been overturned so thoroughly in the past 3 decades that several leading neuroscientists have described the traditional model as essentially backward. The correct model, supported by converging evidence from experimental psychology, computational neuroscience, and clinical neurology, is this. The brain does not wait to receive information and then construct a model of the world. The brain continuously maintains and updates a model of the world and uses incoming sensory data to correct that model. Perception is not bottom-up data processing. It is top-down prediction, calibrated by bottom-up error signals. Your brain, right now, is not watching the world through your eyes. It is running a simulation of the world and checking incoming sensory data against that simulation. When the data matches the prediction, the simulation runs on. When the data contradicts the prediction, a prediction error is generated and the model is updated. What you experience as perception, the vivid, immediate, seemingly direct experience of the world, is the output of the model, not the raw sensory input. Neuroscientist Carl Friston at University College London has formalized this view in the framework of predictive processing, or the free energy principle. In Friston's account, the brain is fundamentally a prediction machine. Its primary function is to minimize prediction error, the discrepancy between expected sensory input and actual sensory input. Perception is the brain's best guess about the causes of incoming sensory signals. Action is the brain's attempt to make the world conform to its predictions. Learning is the brain updating its predictive model in response to prediction errors. The implications for intuition are direct. When you enter a room and feel immediately that something is wrong, without being able to identify what, your brain's predictive model has generated a prediction error. The sensory input does not match the expected pattern. The room is subtly different from what the model predicted. The discrepancy is detected at an unconscious level before the deliberate analysis that might identify the specific anomaly has had time to operate. What reaches consciousness is not the specific anomaly, the out-of-place object, the unusual smell, the person standing slightly wrong. What reaches consciousness is the error signal itself, the feeling of wrongness. This is not a failure of perception. It is perception functioning at its fastest and most general level. The brain flags the anomaly before it has identified the anomaly. The flag is the feeling. The feeling is real information about a real discrepancy between the world and the expected pattern. Research by cognitive neuroscientist Michael Shermer and others has documented a phenomenon they call patternicity, the tendency to find meaningful patterns in noise. This is sometimes cited as evidence that intuitive pattern recognition is unreliable, that the brain generates false signals as readily as true ones. And this is correct as far as it goes. The predictive brain does generate false positives. It sees faces in clouds. It hears voices in wind. It finds patterns in random data. But the error rate and the signal strength are not equal across contexts. Evolved systems tend to produce useful signals in the environments for which they were shaped. The human brain evolved in a social environment of extraordinary complexity. Predators, allies, competitors, potential mates, status hierarchies, coalition politics, and its pattern recognition systems are correspondingly most reliable in the social domain. The feeling that a person is lying, the sense that a social situation is about to become dangerous, the intuition that a negotiating partner's stated position does not reflect their actual priorities. These are the domains in which human intuitive processing is most extensively calibrated by evolution and most regularly validated by experience. The predictive brain is not an oracle, but it is not noise either. It is a hypothesis-generating system that operates at a timescale and a signal integration bandwidth that conscious deliberation cannot approach. What happens to unconscious processing when consciousness turns off? In 2004, German researchers Ulrich Wagner and Jan Born at the University of Lübeck published a study in Nature that produced one of the most striking demonstrations of unconscious processing ever documented. Their subjects were trained on a mathematical problem-solving task that had a hidden shortcut, a structural regularity in the number sequences that, if recognized, would allow problems to be solved in a fraction of the time. Subjects were not told the shortcut existed. After training, some subjects slept before being retested the next morning. Others stayed awake. The subjects who slept were nearly 3 times as likely to discover the hidden shortcut spontaneously as subjects who stayed awake. Sleep, specifically sleep, dramatically enhanced the probability of insight. The sleeping brain, it appeared, was continuing to work on the problem without the person's knowledge or cooperation. This finding was not isolated. It confirmed and extended decades of anecdotal reports from scientists, mathematicians, composers, and writers describing major insights arriving during sleep or immediately upon waking. Auguste Kekulé's discovery of the ring structure of benzene, famously described as coming to him in a dream of a snake eating its tail. Paul McCartney waking to the melody of Yesterday fully formed. Dmitri Mendeleev reportedly dreaming the structure of the periodic table. These stories are often treated as colorful mythology. The neuroscience suggests they represent a real phenomenon. What happens in the sleeping brain that facilitates this kind of processing? Several mechanisms have been identified. During non-REM sleep, the hippocampus, the brain structure primarily responsible for encoding new memories, replays the day's experiences in fast-forward, approximately 20 times faster than real time. This replay does not simply duplicate memories. It appears to extract statistical regularities from the day's experiences, separating the specific episodic details from the underlying structural patterns. Memories are cross-referenced against each other and against previously stored knowledge, finding connections and overlaps that focused conscious attention during waking hours might have missed. During REM sleep, the brain enters a state characterized by widespread activation of associative cortical areas and near-complete suppression of the prefrontal cortex, the region responsible for logical evaluation, reality testing, and the inhibition of implausible connections. In this prefrontal suppressed state, the brain makes connections freely across distant conceptual domains. Association is untethered from plausibility filtering. The dreaming brain combines disparate memories, analogies, and conceptual structures in combinations that would never survive the prefrontal cortex's critical evaluation during waking hours. Most of these combinations are useless, but occasionally the free associative process produces a structural connection of genuine relevance, a relationship between two apparently unrelated domains that, when the prefrontal cortex re-engages upon waking, passes the reality check and reveals itself as a true insight. The aha moment that arrives upon waking is not the processing. The processing happened during sleep. The aha moment is the conscious delivery of a conclusion that the sleeping brain reached hours earlier. This mechanism extends beyond formal problem solving. Research on emotional memory processing has shown that sleep selectively consolidates the emotional significance of memories while sometimes reducing the emotional intensity of the raw experience. A traumatic or distressing event experienced before sleep is often remembered the next morning with the same factual content but diminished raw emotional impact. The memory retains its informational value, the information about what happened and why it was significant, while the raw physiological response is attenuated. Sleep does not erase the lesson. It metabolizes the distress, preserving the signal while reducing the noise. This suggests that the sleeping brain is performing a kind of information refining process, extracting meaning from experience, building predictive models, making connections, and updating the subconscious knowledge base that waking intuition will draw on in the days and years ahead. Every night, without your knowledge, your brain is doing homework. Kabya. The body is the unconscious. Interoception and the intelligence of physical sensation. In 2010, neuroscientist Barnaby Dunn and colleagues at the Medical Research Council in Cambridge published a study examining the relationship between interoception, the brain's processing of internal body states, and intuitive decision-making. They asked subjects to perform the Iowa gambling task while simultaneously monitoring their own heartbeat. Subjects who were more accurate at detecting their own heartbeat, a standard measure of interoceptive sensitivity, made better choices on the gambling task. Not just slightly better, meaningfully, significantly better. And when asked about their choices, the high interoception subjects were more likely to report basing their decisions on a gut feeling. The study pointed to something that Damasio's somatic marker hypothesis had proposed but not directly tested. The accuracy of intuitive processing depends partly on the sensitivity of the channel through which the unconscious communicates with consciousness. The unconscious brain broadcasts its conclusions as physical sensations. Conscious awareness receives those sensations and translates them into feelings, hunches, and intuitions. If the channel is poor, If interoceptive sensitivity is low, the signal is degraded. The hunch is fainter, less compelling, more easily overridden by deliberate reasoning that may be less accurate. Interoception is the perception of the body's internal state. It includes the detection of heart rate, breathing rhythm, gut motility, pain, temperature, and a host of more subtle physiological signals coordinated by the insula, a cortical region buried deep in the lateral sulcus of the brain. The insula receives input from virtually every organ and tissue in the body, integrating these signals into a continuous representation of the body's current state. Neuroscientist A.D. Craig at the Barrow Neurological Institute has described the insula as the seat of subjective feeling, the place where raw physiological data is transformed into conscious emotional experience. The gut-brain connection that popular culture refers to when it speaks of gut feelings is not metaphor. The enteric nervous system, the network of approximately 500 million neurons lining the gastrointestinal tract, is the largest collection of neurons outside the brain itself. The vagus nerve carries bidirectional signals between the gut and the brain, with approximately 80% of its fibers running from gut to brain rather than from brain to gut. The gut is not simply responding to the brain's instructions, it is sending continuous information upward. The specific contents of that information remain an active research area. What is established is that gut microbiome composition influences neurotransmitter production, that disruptions in gut-brain signaling are associated with emotional dysregulation and decision-making impairment, and that the visceral sensations associated with emotional and intuitive states, the stomach drop of fear, the warmth of affection, the nausea of moral revulsion, are not post hoc rationalizations of brain states. They are components of those states, generated by real physiological changes coordinated by the nervous system, and they carry information that the conscious mind uses to navigate uncertainty. The phrase, "trust your gut," is not folk wisdom. It is a reasonably accurate description of a genuine neural pathway. Tapiate. When intuition fails. The systematic errors of the unconscious mind. Intuition is not always right. This needs to be said clearly because the neuroscience of intuition is sometimes weaponized by popular culture into a permission structure for never questioning your first instinct, a misreading of the research that can be genuinely dangerous. The unconscious brain is extraordinarily powerful. It is also biased, incomplete, and shaped by experience in ways that can produce systematic errors with great confidence. The first and most significant source of intuitive failure is base rate neglect. The unconscious pattern recognition system is calibrated to the statistical regularities of the environments it has been exposed to. It has no mechanism for correcting for biased sampling. If your formative experiences occurred in an environment where a particular category of person was associated with a particular behavior, your intuitive responses to that category will reflect that association regardless of whether it holds generally. The unconscious does not know the difference between a representative sample and a biased one. It knows what it has seen. This is the neural mechanism underlying stereotypes and implicit bias. Researchers at Harvard University's Project Implicit have documented that implicit associations, the unconscious connections the brain makes between concepts, frequently diverge from explicit, consciously held beliefs. A person who consciously believes in racial equality and would be genuinely distressed by the suggestion that they harbor racial bias may nonetheless show measurable implicit associations that link certain racial categories with negative attributes. These associations are not beliefs in the conventional sense. They are pattern connections built by a brain that has been exposed to a culturally biased information environment and has extracted the statistical regularities of that environment faithfully and without moral evaluation. The feeling of intuitive certainty provides no information about whether the pattern being recognized is accurate or biased. The feeling is generated by the match, not by the validity of the match. The second major failure mode is hindsight bias, the brain's tendency to reconstruct memories of prior uncertainty as having been more predictable than they were. After an outcome occurs, the brain retroactively adjusts its representation of what it knew before the outcome. This adjustment happens unconsciously, automatically, and without awareness. The result is that people consistently overestimate the accuracy of their prior intuitions because their memory of those intuitions has been contaminated by knowledge of how things turned out. This is one reason that the confident assertion, "I had a feeling that would happen," is very often inaccurate, not because the person is lying, but because memory is reconstructive, and the reconstruction has been contaminated. The third failure mode is what psychologist Paul Slovic has called the affect heuristic, the substitution of emotional response for factual assessment. When making judgments about probability, risk, or quality, people consistently substitute the question, "How do I feel about this?" for the question, "What does the evidence indicate?" A nuclear power plant rated as high risk and low benefit in one study was rated as low risk and high benefit in another study where subjects were first primed with positive affect toward nuclear technology. The underlying factual data did not change. The emotional valence changed and the intuitive assessment changed with it. The affect heuristic is not always wrong. Emotional responses often carry real information, but it fails systematically in situations where the emotional response is disconnected from the actual risk or value, where, for instance, the emotional response is driven by vividness, familiarity, or cultural framing rather than by the statistical properties of the situation. Psychologist Daniel Kahneman, whose work integrating research on judgment and decision-making earned him the Nobel Prize, has described the conditions under which intuition can be trusted. Environments that are regular enough to be learnable, where the learner has had sufficient practice and feedback to build an accurate pattern library, and where the feedback has been timely and accurate enough to allow genuine calibration. Chess, poker, certain medical diagnosis tasks, experienced firefighting. These meet the criteria. Stock market prediction, clinical psychology for outcomes measured over years, political forecasting. These largely do not. In irregular, high-variance, slow feedback environments, expert intuition frequently degrades to sophisticated noise. The hard and uncomfortable truth is that human beings are generally poor at knowing when their intuitions are reliable. The feeling of certainty is generated by pattern matching, not by accuracy. An expert in a regular environment and an overconfident amateur in an irregular one both experience the same quality of intuitive conviction. The neural signal of knowing feels the same regardless of whether you actually know. Chabwadiaze Zalmi. The social brain. Intuition as evolved intelligence for reading other minds. Of all the domains in which unconscious processing has shaped human intuition, none is more refined or more consequential than the domain of social cognition, the ability to model, predict, and respond to the mental states of other people. Human beings are, by evolutionary standard, extreme social specialists. For the vast majority of our species' history, survival and reproduction depended on navigating extraordinarily complex social environments. Environments where the ability to accurately model other people's intentions, detect deception, anticipate coalitional shifts, identify allies and rivals, and calibrate trust was the primary determinant of fitness. The physical environment of the African savanna posed challenges that brute physical capability and basic tool use could address. The social environment, a world of shifting alliances, contested status hierarchies, resource competition, and the ever-present problem of cheating in cooperative arrangements, posed challenges that required computation of a fundamentally different kind. Evolutionary psychologists Robin Dunbar and colleagues have proposed what has become known as the social brain hypothesis, that the extraordinary expansion of the neocortex in the primate lineage, culminating in the massive human brain, was driven not primarily by ecological challenges, but by the computational demands of social life. The size of the neocortex across primate species correlates more strongly with typical group size, and therefore with the complexity of the social environment to be navigated, than with any measure of ecological challenge. If this hypothesis is correct, then the human brain is fundamentally, architecturally, a social prediction machine. And the intuitive capabilities that are most refined in humans, reading facial microexpressions, detecting vocal stress, identifying the incongruence between stated and actual emotional states, sensing when someone's social presentation is misaligned with their true intentions, are not mysterious extras tacked onto a general-purpose intelligence. They are the primary output of the neural systems for which the brain was most strongly selected. Paul Ekman's research on facial microexpressions, fleeting facial movements lasting between 1/15th and 1/25th of a second that involuntarily reveal emotional states the person may be consciously suppressing, demonstrated that human beings have the capacity to detect these expressions, though most people do so unreliably under normal conditions. Training can substantially improve detection rates. What is more interesting is that some individuals show naturally high accuracy in detecting microexpressions, typically without knowing that they are doing so. Their experience is not, "I detected a microexpression indicating suppressed anger." Their experience is, "Something felt off about that interaction." The detection happened. The conclusion traveled up through unconscious processing. What arrived at consciousness was a feeling, not a fact, and the feeling carried accurate information about a real signal. Mirror neuron systems, first discovered in macaque monkeys by Giacomo Rizzolasti and colleagues in the 1990s, and subsequently identified in human neuroimaging research, provide another component of social intuition. Mirror neurons, or more precisely, the mirror neuron system, since it appears to be a distributed network rather than a discrete cell type, activate both when you perform an action and when you observe another person performing the same action. When you watch someone lift a heavy object, neurons associated with the motor patterns of lifting activate in your brain. When you watch someone wince in pain, pain processing systems activate, though at reduced magnitude. When you watch someone express an emotion, related emotional processing occurs in you. This system has been proposed as a neural basis for empathy, the felt sense of another person's experience. But it also provides a mechanism for prediction. By simulating another person's actions and states in your own motor and emotional systems, your brain generates predictions about what that person is likely to do next. These predictions are fast, automatic, and largely unconscious. They appear in experience as the intuitive reading of a person's mood, the anticipatory adjustment to someone's likely objection before they raise it, the immediate sense of another person's emotional state that does not require verbal communication. This is the neural substrate of what is sometimes called emotional intelligence, and it operates primarily below the threshold of conscious deliberation. The decision before the decision. What neuroscience says about free will and unconscious choice. In 1983, neurophysiologist Benjamin Libet at the University of California, San Francisco, published the results of an experiment that has generated more philosophical controversy than perhaps any other finding in modern neuroscience. Libet asked subjects to flex their wrist at a moment of their own choosing, while monitoring their brain activity via electroencephalogram and asking them to note the position of a clock hand at the moment they first felt the intention to move. The result was deeply disorienting. The brain showed a characteristic pattern of electrical activity called the readiness potential, which had been known since the 1960s to precede voluntary movements. What Libet found was that the readiness potential began approximately 500 to 1,000 milliseconds before the movement occurred. Conscious awareness of the intention to move appeared approximately 200 milliseconds before the movement, roughly 300 to 800 milliseconds after the readiness potential had already begun building. The unconscious neural activity that was constructing the movement had begun well before the person was consciously aware of any intention to move. The conscious experience of deciding appeared not to initiate the movement, but to accompany it and to arrive late. Libet himself was careful about the interpretation, noting that his subjects could still consciously veto the movement after becoming aware of the intention, and proposing that conscious will might function as a final stage filter rather than an initiator. Subsequent research has complicated the picture substantially. Later studies using fMRI have suggested that the pattern of brain activity can predict which of two choices a subject will make up to 10 seconds before the subject is consciously aware of making the decision. Researchers John Dylan Haynes and colleagues at the Max Planck Institute for Human Cognitive and Brain Sciences published this finding in 2008 with accuracies of approximately 60%, small but significant above chance, and deeply challenging to the intuitive sense that conscious decisions originate at the moment we experience making them. The Libet experiment and its successors do not definitively prove the absence of free will in any philosophically rigorous sense. The debates about determinism, compatibilism, and the nature of agency that these findings have generated among philosophers remain genuinely unresolved. But they do reveal something specific and relevant to the neuroscience of intuition. The boundary between conscious and unconscious processing is not located where subjective experience places it. Processes that the experiencing mind attributes to conscious, deliberate choice may be initiated by unconscious mechanisms. The experience of deciding may be, at least in part, a post hoc narrative constructed by consciousness to account for outputs that were generated elsewhere. This is not a counsel of nihilism. It does not follow that deliberate thought and conscious reasoning are useless or that agency is an illusion. What it suggests is that the traditional picture in which consciousness is the master and the unconscious body merely executes its commands, has things partially reversed. The unconscious brain is not the servant of conscious thought. Conscious thought is one process among many that the brain runs, and the relationship between them is interactive, bidirectional, and far more entangled than the subjective experience of thinking would suggest. Chaparina. Cultivating the channel. How to improve your intuitive accuracy. If intuition is a real signal that can carry genuine information, but is also subject to systematic biases and failures, the question becomes, how do you improve it? How do you calibrate the channel? How do you distinguish the signal from the noise? The research suggests several converging principles. The first is domain immersion. Intuitive accuracy is tightly domain-specific. You cannot develop reliable medical intuition without extensive exposure to medical cases and feedback. You cannot develop reliable social intuition in a particular cultural context without extensive experience in that context. You cannot develop reliable creative intuition in a domain without extensive immersion in the domain's history, conventions, and possibilities. The breadth of your unconscious pattern library is a function of the breadth and depth of your experience. There are no shortcuts. Gary Klein's research on expert decision-making found that the primary variable distinguishing reliable from unreliable intuition was not raw cognitive ability, but the quality and quantity of experience combined with the quality of feedback. Experts who had learned their craft in environments with clear, timely, accurate feedback about the outcomes of their decisions developed reliable intuition. Those who had learned in environments with delayed, ambiguous, or absent feedback, or whose experience was rich in quantity but poor in variety, developed confident intuition that was frequently wrong. This means that actively seeking feedback on intuitive judgments is not just a practice for improving explicit reasoning. It is the mechanism by which the unconscious pattern library is calibrated. Every time you commit to a judgment, wait for the outcome and register whether you were right or wrong. You are training the system. Every time you make a judgment without following up, without ever finding out whether you were right, you are leaving the training data on the table. The second principle is somatic awareness. The channel through which the unconscious communicates its conclusions to consciousness is the body. Improving interoceptive sensitivity, the ability to accurately perceive your own physiological states, improves the signal quality. Research on mindfulness meditation has documented measurable increases in interoceptive accuracy following sustained practice. Heart rate detection tasks, where subjects are asked to count their own heartbeats during a period when no external cues are available, show improved accuracy in meditators compared to controls. And as Barnaby Dunn's research showed, better interoceptive accuracy correlates with better intuitive decision-making. Body-based practices, not because of any mystical framework, but because of what they do to the neural circuitry of interoception. A person who has developed the capacity to notice subtle physiological shifts, the barely perceptible change in breathing rhythm, the slight tension in the chest, the very faint nausea that precedes a somatic warning, has access to a richer signal than a person who only notices sensations when they are intense. Developing that sensitivity requires practice, not because the signals are not there, but because the default attentional habits of modern life point awareness outward rather than inward. The third principle is deliberate incubation, learning to allow problems to process without forcing conscious resolution. The research on sleep-dependent insight and the broader literature on incubation effects in creative problem-solving consistently show that performance on insight problems is improved by interrupting deliberate attempts to solve them and allowing time, often with sleep, before returning to them. The improvement is not explained by rest alone. It is specifically produced by the unconscious processing that occurs during the interruption, most productively during sleep. The practical implication is that for genuinely complex problems, those where the answer is not accessible to deliberate analysis, where the relevant variables are too numerous or interconnected to be held in working memory simultaneously. Investing in sleep before deciding is not laziness. It is resource allocation. Framing the problem clearly before sleep, then genuinely allowing the period of sleep to intervene before deliberating further, appears to maximize the probability of insight-driven solutions emerging. The fourth principle is perhaps the most counterintuitive: learning to distrust your intuition about your intuition. The metacognition, the sense of knowing that you know, the feeling of confidence about an intuitive judgment, is not a reliable signal of accuracy. Overconfident intuitive certainty is one of the most well-documented features of expert cognition. The mechanisms that generate the feeling of knowing and the mechanisms that ensure accuracy are distinct, and calibrating them requires specific effort. Psychologist Philip Tetlock's landmark study of expert political forecasters, described in his 2005 book Expert Political Judgment, found that experts who described their reasoning in terms of single large organizing ideas, the intellectual style he associated with hedgehogs, showed worse calibration and worse predictive accuracy than those who drew on multiple analytical frameworks and explicitly acknowledged uncertainty. The hedgehog's confident, forceful intuitions, the kind that make for compelling television punditry, were consistently less accurate than the more tentative, probabilistic, multiply-framed assessments of the foxes. The best intuition, paradoxically, is the intuition that knows its own limits, that can say, "I have a strong feeling about this, but I'm uncertain whether to trust it here, because this is not a domain where I have reliable feedback experience." That metacognitive capacity does not diminish intuition. It channels it toward the domains where it is actually reliable. The creative unconscious. One ideas arrive in the shower. Every person who has worked on a genuinely difficult creative problem has had the experience. You sit at your desk and think and think and think, and nothing comes. You are consciously attending to the problem with full effort, and the problem refuses to yield. Then you stand up, you walk away, you take a shower or a walk or a long drive, or simply fall asleep. And the answer arrives, fully formed, unbidden. As if it had been waiting just outside the room and found the door open the moment you stopped pushing against it. This is not a mystical experience. It is the direct result of what happens when focused analytical attention releases a problem and unconscious associative processing takes over. Graham Wallace, in his 1926 book The Art of Thought, proposed a four-stage model of creative insight that has held up remarkably well against subsequent neuroscientific research: preparation, incubation, illumination, and verification. Preparation is the period of focused conscious work on a problem. Incubation is the period of apparent rest during which unconscious processing continues. Illumination is the moment of insight. Verification is the subsequent conscious work of evaluating and elaborating the solution. The key stage, the one that popular accounts of creativity both celebrate and mystify, is incubation. What is the brain actually doing during incubation? Several mechanisms have been identified. The first is spreading activation, the unconscious propagation of activation through associative networks. When you consciously think about a problem, you tend to activate the same conceptual networks repeatedly, traversing the same pathways that past thinking has strengthened. This is exactly what makes focused conscious effort good at exploiting known pathways but poor at finding new ones. When conscious attention is released from the problem, spreading activation continues through associative memory, but it now propagates freely through the entire network, including distant and weakly connected regions that focused attention would never have reached. The default mode network, a set of brain regions including the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus, is most active when conscious attention is not directed at an external task. This network, once dismissed as resting state activity, has been identified as the neural substrate of spontaneous thought, mind-wandering, and autobiographical memory retrieval. Critically, it appears to be a primary site of associative integration, the combination of information from disparate memory systems that underlies creative insight. Brain imaging studies of subjects solving insight problems have documented a distinctive pattern. Immediately before subjects report an aha moment, there is a burst of high-frequency neural activity in the right anterior temporal lobe, a region associated with the integration of distantly related information. This burst is preceded by a brief period of visual alpha wave activity, suggesting a temporary gating of visual input, the neurological equivalent of a looking inward rather than outward. Consciousness briefly turns away from external attention, and in that moment, the insight surfaces. The shower produces insight not because water is magic, but because the shower is one of the few contexts in modern life where the combination of mild physical automaticity, sensory monotony, reduced opportunity for digital distraction, and a slightly elevated body temperature, which appears to facilitate associative breadth, allows the default mode network to operate without competition from externally directed attention. You have given your unconscious a quiet room. It has been working on your problem the entire time. It hands you the answer when you finally stop interrupting. Chapter: The limits of the conscious mind. And why that should change how you live. Everything in this script has been building toward a single realization. The conscious mind, the part of your mental life you identify as you, the narrator, the planner, the deliberator, the one reading these words, is not running the show. It is receiving a curated broadcast of the show's highlights, produced by systems it did not design and cannot directly access, transmitted through channels it did not build. This is not a statement about the limitations of one particular mind. It is a statement about the architecture of human consciousness. It applies to every human brain that has ever existed or ever will exist. The ratio of unconscious to conscious processing in the brain is not a defect to be corrected. It is the solution evolution arrived at for the problem of navigating a complex world in real time with finite computational resources. Consciousness is extraordinarily powerful within its domain. The ability to hold a narrative, to consider hypothetical futures, to construct logical arguments, to communicate with symbolic language, to accumulate and transmit culture. These are capabilities of conscious deliberation that no other species possesses to anything like the human degree. They are real advantages that have allowed the human lineage to achieve things no other animal has approached. But they are not free. Conscious deliberation is slow, narrow, and metabolically expensive. It is the right tool for problems that require logical chains, symbolic manipulation, and temporal perspective across long timescales. It is the wrong tool for problems that require the rapid integration of thousands of simultaneous signals, pattern recognition in complex high-dimensional spaces, or the real-time navigation of social dynamics where the relevant data is encoded in micro-expressions, vocal micro-fluctuations, and postural subtleties that unfold in milliseconds. For those problems, the problems of immediate perception, of social navigation, of creative insight, of expert performance under pressure, the unconscious systems are simply better, faster, wider, more deeply calibrated by experience, and operating on a signal bandwidth that consciousness cannot match. The practical implication is not to abandon deliberate thought. It is to stop treating deliberate thought as the gold standard of mental performance and unconscious intuition as an inferior, unreliable backup system. The evidence does not support that hierarchy. What the evidence supports is a more nuanced view. Different cognitive tools for different cognitive tasks, with the wisdom to distinguish which tool is appropriate for which task. The person who never questions their intuition, who treats every gut feeling as infallible truth, is at the mercy of whatever biases and incomplete experiences shaped their unconscious pattern library. They will be confidently wrong in systematic and predictable ways. The person who never trusts their intuition, who subjects every perception and decision to exhaustive conscious analysis, who overrides the felt signal every time deliberate reasoning produces a different answer, is throwing away information, often the best information available, because it arrived through a channel they cannot see. The integrated use of both systems, conscious deliberation to set goals, evaluate evidence, correct for known biases, and verify conclusions. Unconscious processing, to perceive patterns, generate hypotheses, read social situations, and identify the action when deliberation is too slow, is what the neuroscience of expertise consistently shows in its most capable subjects. The chess grandmaster does not pick up the pieces deliberately for the first 20 moves and then switch to intuition for the endgame. The intuitive pattern recognition and the conscious strategic calculation operate simultaneously, each informing the other. The firefighting commander does not either trust instinct blindly or override it with checklist analysis. The intuitive signal is a datum in a broader assessment, a flag that directs conscious attention, a hypothesis to be tested in the milliseconds available. This integration is learnable. It is developed through exactly the mechanisms discussed. Deep domain experience with quality feedback, somatic awareness cultivated through interoceptive practice, deliberate incubation of complex problems, and the hard-won metacognitive skill of knowing when to trust your gut and when to question it. For 14. The frontier. What neuroscience still does not know. Honesty requires acknowledging how much of this picture remains incomplete. The neuroscience of intuition is one of the most active and contested areas in all of cognitive science. The research is real, the phenomena are real, but the mechanisms remain partially understood. The mapping from neural activity to subjective experience is still a deep unsolved problem. and several of the most prominent findings in the field have faced replication challenges that complicate their interpretation. The mirror neuron system, once described by neuroscientist Vilayano Ramachandran as the neurons that shaped civilization and proposed as the mechanism of empathy, theory of mind, and language acquisition, has been substantially qualified by subsequent research. The existence of mirror-type neural activity in humans is not in doubt, but its interpretation, whether it constitutes a dedicated mind-reading system or is a more general property of learned associations, remains contested. The social priming research that suggested unconscious exposure to words associated with age caused subjects to walk more slowly, or that holding a warm coffee cup increased judgments of a stranger's warmth, has not survived rigorous replication attempts. The general principle that unconscious priming influences behavior is robustly supported. The specific claims about the magnitude and directness of these effects have been substantially reduced. The interpretation of the Libet experiment as evidence against conscious free will has been challenged on multiple methodological grounds, including the accuracy of retrospective timing judgments, the representativeness of simple wrist flexion as a model of real decision-making, and the possibility that the readiness potential reflects the preparation of a potential movement rather than a commitment to perform it. What remains solid, what has been replicated across laboratories, methods, and cultural contexts with sufficient consistency to be treated as established, is the following. The brain processes vastly more information than consciousness accesses. Emotional and somatic states generated by unconscious processing substantially influence decision-making. Expertise produces unconscious pattern recognition that is functionally superior to deliberate analysis in its domain. Sleep facilitates insight and memory integration through mechanisms that involve unconscious associative processing. Intuitive certainty is not a reliable guide to intuitive accuracy. These are the foundations. They are substantial. They are real. They change what it means to understand your own mind. The rest, the fine-grained neural mechanisms, the precise conditions under which intuition can be trusted, the question of whether consciousness has any independent causal power over behavior or merely registers what the body has already decided, these remain open. The science is younger than the questions it is trying to answer. What can be said is that the phenomenon people call intuition, gut feeling, or the sixth sense is not supernatural. It is not coincidence. It is not noise. It is the output of a brain that is constantly processing more information than you will ever be aware of, making predictions, detecting patterns, and communicating its conclusions to consciousness through the only language available before deliberate thought can convene. The language of feeling, sensation, and the deep bodily knowing that something you do not yet know what is true. Clucky Calty. Gang, you started this video with an experience everyone has had. The moment of knowing without knowing how you know. The gut feeling that was right. The sense of wrongness that saved you from something. The creative insight that arrived uninvited. The social perception that bypassed analysis and landed directly. You now know more about where that experience comes from than most people ever will. You know that it comes from a brain running approximately 11 million bits of information per second below the threshold of consciousness. That it is built from decades of experience encoded in the pattern libraries of an expert system that never sleeps, never rests, and never stops processing the world. That it is communicated through the body, through the physical sensations that the insular and the autonomic nervous system use to translate unconscious conclusions into something consciousness can receive. That it is refined by experience with feedback, degraded by biased environments, systematically skewed by the effect heuristic and the limitations of what the pattern library has been allowed to learn. You know that it is real information, and you know that it is imperfect information, and you know, because this is the genuinely difficult part, that distinguishing between the two in real time under real pressure is a skill that must be developed rather than assumed. The sixth sense is not magic. It is the oldest, fastest, most deeply integrated sense you have, the one that was processing the world before language existed, before deliberate thought was possible, before consciousness as we know it had evolved. It is what your brain does before your mind gets involved. The question is not whether to trust it. The question is how to use it. And the answer, as with most things worth knowing, begins with understanding what it actually is. If this video changed the way you think about your own mind, consider sharing it with someone who might need to hear it. The brain works best when it has good information. Now it has a little more.